we'll now quickly look at a few more examples of classifying three-dimensional figures and then kind of naming some important parts about the figure. Okay, so this is the figure that we have. It looks, like we don't really have any faces that are parallel to each other, right? So that kind of means that, this is not going to be a prism, okay? But it does look like it has, a lot of these faces kind of come to a point right up here at F. Right, so to me this almost looks more like a pyramid, right? And so in order to properly name this, we really have to look at the base, right? And it has 1, 2, 3, 4, 5 sides there, so that's a pentagon, right? It's a pentagonal base, and then these triangles, which I'll outline maybe in green here. These triangles, okay, there's 5 of them, right? And the triangles kind of all form and connect at the top, okay, at F, right? So to me, this would be classified as a pentagonal pyramid. Okay, so that's our answer for classifying. Okay, I'm going to go ahead and erase this a little bit now, and we have to kind of answer the rest of the problem here, right? So let's look at the vertices, right? So for the vertices, we want to go ahead and label all of these. Pretty simple task, I would say. Basically, you're looking at all the letters, right? So again, the vertex is going to be where 3 different faces meet at a point, and so our vertices in this case would be F, and I'll just call it A, B, C, D, E. Okay, those are all of our vertices, right? So it's those corners, those corner points where 3 different faces actually meet. Okay, let's look at edges now, right? So edges are just going to be kind of those straight lines where 2 different faces actually meet, right? So let's look at edges. Okay, so edges, I could call DE an edge. Okay, I could call EA an edge. I could call AB and BC edges. Okay, definitely CD would be an edge. Okay, and then there's going to be a few more here, right? So AF will be an edge. BF, CF, DF. And then finally, EF, right? And I recommend doing it just like I am, kind of like marking these along as you go. That way you don't forget any. But it looks like this particular one has a total of 10 edges. And then finally, it wants us to confirm our base. Well, our base is just this one that we identified as the base to this pentagonal pyramid. And so the base here in this case, we would just call, let's just call it pentagon ABCDE. Okay, so again, pretty simple example. Let's just look at a couple more here for good measure. Okay, so here are a couple more. It says classify the figure, name the vertices, edges, and bases. Okay, well, if we take a look at this, it looks like an ice cream cone, right? So I can see that we have like this circular base here. Okay, and it has like this curved surface that all connects to this point, right? So I'm just going to call this a cone. Okay, now we want to name the vertices. Well, this only has one vertex. Okay, this vertex is just going to be the point N, right, where this curved surface kind of like meets at a point. Okay, for edges, okay, well, we don't have any straight edges on this, right? So for edges in this example, we would have to write none. Okay, and for the bases on this particular one, the base here we could just call this circle. What could actually be our base. So I'm just going to call this point C, right? So our base at this point we could call like circle C. Would be a base there. Okay. Let's look at this other figure here. Okay. So on this next one, it looks like we have. Let's see. I can maybe identify a couple of sides here that are opposite of each other, that look kind of parallel here, okay, that are maybe connected in 1, 2, 3 places there, okay. So to me this looks like, well, it's a triangular base, okay. I have these 2 faces that are opposite of each other, right? 1 and 2, they look parallel and they look like they're connected by these different parallelograms, right? So to me, this is a triangular prism. Okay, and now at this point we want to continue and go ahead and name all the vertices, right? So the vertices in this case would be, we're just naming pretty much all the letters, right? So I'm going to do a little bit of erasing here. So erase, erase, erase. Okay, and let's go ahead and look at our vertices, right? So I could call it W, X, Y, and then it's going to be U, T, and V. Those are all my vertices, okay? Let's look at edges now, all right? So I'm going to use purple for edges so it really actually shows up on this picture, right? So edges, in this case, would be TW, TV, segment VU, segment UT, segment VY, segment YX, segment XW, segment XU. Let's see if we missed any here. There should be one in the back sort of connecting these two. Okay, so I'll say segment WY. Okay, let's see, are we missing any? We have this edge, this edge, this edge. 1, 2, 3. We should have 9 total. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so this is definitely good at this point. Okay, so we'll look into kind of a couple different things in the next series of videos where we talk more about nets and things like that.